Welcome everyone. Um, I am Nathaniel Osgood. I'm your instructor for this course on agent-based and individual-based modeling this semester. This is a course that, per its title, spans theory and practice. And it will bring us through a broad set of issues in some depth on the topic of these computational models, known variously as individual-based models and agent-based models. Our particular focal area for the semester will be in applications to health. However, I will, on occasion, and with a fair bit of frequency during the semester, be touching on other areas of application, whether it be ecological issues, on occasion, potentially issues having to do with business and management, which I know is of interest to some of you, social concerns and issues, and other topics. So it won't be exclusive to focus on health, but it will be a recurrent theme. And in the sphere of health, we'll be talking about both applications in communicable disease, chronic disease, behavioral issues, and zoonoses and other topics. Okay, we have a lot that I'd like to ideally cover today, and we are bound by the strictures of time. I'm used to teaching relatives of this course for an hour and a half sessions, but we have afforded us 3 one-hour lecture sessions a week, plus a lab session. And this will require a little bit of restructuring from my normal presentation style, but it shouldn't be anything too major in its in what it constraints. Okay, I am going to go start showing some slides. This will be an ongoing medium for the class, but I will also make use of the whiteboards here and probably a tablet. Some of you are familiar with locally with my tablet use, and we'll probably use that to, on occasion, just sort of have better communication of sketching than what we can afford in the whiteboard. Okay, so let me start by sharing, and I am getting a little bit of slowness here with Zoom, but I think this should be suitable. Again, can anyone on Zoom indicate that you can currently see my slide? Okay, great. Okay, so my goals for today are first and foremost to situate you with respect to the class, set expectations, discuss coverage, and talk a little bit about the assessment instruments at different of the co-located courses. I will also speak in a little bit more detail about the major focus of course activity for student contributions and deliverables, which is the project. As time allows, we may dive into a model. And in fact, on both the Fields LMS and the Canvas site for University of Saskatchewan, I did post a model, but we may not have time to substantively explore it in today's session, in which case that will be pushed to Wednesday. Okay, so the objective of this course is really to provide not just a glancing introduction to agent-based modeling, as I do. Folks are familiar in my Introduction to Modeling course, but really a systematic introduction to different aspects of agent-based modeling, specifically the concepts, formalisms. I'm thinking about constructs such as state charts and use of networks, and spatial formalisms such as tessellating a plane with cells, etc. Underlying mathematics and sort of modeling perspective of agent-based and individual-based model. And we seek to do this in practical pursuit of topics. Okay, we don't need that. In form of projects, in a way that will, as I say, prominently feature health applications, but not be exclusive to them. So let's talk about some topics. And I'm going to have to bring these little widgets around in hopes that they won't obscure the screen too much. So within this course, we'll be talking about a variety of materials, but certain themes and certain issues will come up either in particular lectures or clusters of lectures on the one hand, or in a sort of cross-cutting way. There are some topics such as involving emergence and dynamics that are really cross-cutting, and this interaction between context, mechanism, and outcome, which is describing a combination that comes out of critical realist ideas, but which really fits like a glove to agent-based modeling, where we depict mechanisms, where we capture context in the form of networks and spatial context or topological context, and social context, nested context, and where we're interested in outcomes, and particularly emergent outcomes. We'll talk a lot about the upwards-facing perspective of agent-based models. Agent-based modeling is not infrequently referred to as modeling from the ground up or from the bottom up. I have a little bit of problem with that because, as we know as modelers, typically there's not a canonical bottom to our modeling scope. And I think what's fair to say, and what is incontrovertibly true, is that with agent-based modeling, we're considering how micro-behavior of many different populations of agents interacting, many particular individuals, lead to meso and macro behavior as well, behavior at higher levels. We're not imposing some predefined understanding of dynamics at a macro level and understanding the lower level implications. Rather, we're sort of percolating up emergent dynamics. We're going to be talking about the role of heterogeneity, of differences between agents, and how that serves as a central point of attraction for use of these methods. The fact that we want to distinguish agents of different sorts. And often from a health perspective, and indeed from a social perspective, this is tied in with notions of equity, concern of disproportionate empowerment or enfranchisement of people of different sorts, different reach of our social or health programs, etc. And this ability to capture heterogeneity in a scalable way, in a way that as we are interested in more heterogeneity or examining it through a new lens of an extra heterogeneity dimension, ABMs accommodate that. Individual-based models accommodate that vastly more comfortably and more nimbly than do the new aggregate models. They scale better, but they're also just more agile and allow much easier learning and modifications of models. It's more tailored rather than requiring changes across the entire model. We'll talk about network structure. And for those with a bit more math exposure, talk about the ways in which we can go beyond networks to simplicial complexes and think about cliques of agents or groups of agents that might interact with each other and be characterized in higher level simplices. Higher simplices of a simplicial complex. We will talk some about the notion of state space within this model on a recurrent basis. And note that there's an exceptionally large and a truly stupendously large dimensionality nominally of state space when we have agents, because each agent contributes to a combinatorial explosion in the number of possibilities. If each agent can be in only one of two states, which would be an impoverished agent indeed, and we had n agents, we'd have 2 to the n possible possibilities. With but 10 agents, we'd have 1,024, right? And the scaling there exhibits the curse of dimensionality. But the fact is that we see the emergence of manifolds. We see low dimensional behavior emerge out of this in really powerful ways. And it's very visible, and it emerges not for any sort of mysterious reason, but because of agent coupling and conservation properties and certain symmetries like we see in real world systems of high dimensionality. So often the behavior of an agent-based model exhibits low dimensional regularities. And we're going to talk about that some in this class. About often we see very recognizable patterns, such as macroscopic oscillations in a predator-prey model that emerge from many, many individual interactions. Right? Even in very complex, descriptively complex contextual contexts with spatial linkages and networks between individuals, etc. We'll talk about the really big role, really big insights that can come from a longitudinal perspective. This is oft too little talked about. Dynamic models, many of you will be very familiar with aggregate models, perhaps compartmental models. You may call them stock and flow models, but they're aggregate ones, characterizing the number of people, for example, that might be in a given health state and transitions between them. What those models give us is cross-sectional depictions of a population over time. It does give behavior over time, but it's cross-sectional. It doesn't give us an understanding of the history of a given individual, their story. And agent-based models, by contrast, provide this really powerful way of storytelling, even at an individual level, in terms of what I call here longitudinal trajectories. But basically what it has to do with is we can accumulate, we can reason about, we can match against empirical data, we can intervene based on people's histories. Right? We could focus certain treatments on individuals who have come to a clinic at least 3 times in the past, for example, or have a history of certain types of adverse behaviors involving, domestic disturbances or what have you. We can look at someone's history from a oral health perspective and use that to shape the care that they receive in terms of extra tutoring to help them better equip them to engage in better oral health practices. I'm using examples from some of our work. Interventions are a key need here, and what's really important to understand is that interventions can take advantage of all these characteristics. I just mentioned interventions with respect to longitudinal history, but also with respect to heterogeneity. I referred to it with respect to mesoscopic and macroscopic behavior. We may decide to intervene within a system based on aspects of what's going on at different levels of the system or different points in a network. If we can represent networks, we can capture network-related interventions, and in some cases build up networks such as social support groups, walking groups, for example, that support people's behavior. And we can represent those in an agent-based model in a way that would generally be, at the least, very blunt and crude in an aggregate model, but is very readily characterized within an individual-based model. We'll talk a lot about situated perception in this. I know, Matthews, this is one area where you and I were recently talking with respect to the Sugarscape classic model, for example. And it's very much a motivation for use of individual-based and agent-based modeling. If we're interested in understanding the dynamics of traffic jams, it behooves us to understand how agents on the roads, what they perceive, what they don't perceive, because often that's related to their behavior in terms of tapping their brakes. If they're going to be going around a curve and they can't see what's ahead, they may tap their brakes. If the weather conditions are adverse, they will tend to drive slower because they can't see the vehicles, too many cars ahead of them, for example. They can't see what's going on further down. Similarly for driving at night, right? Here in our area, you have issues with, for example, deer that come onto the road or moose, right? Elk on occasion. Well, okay, I won't enumerate all the faunal variety that we have recommending us, but the point is, people drive differently based on local perception, based on what they can perceive, their behavior reflects that. And I would argue it's similar in many cases for getting a vaccine or seeking treatment for symptoms of some condition. Often your behavior in your social network, those around you in your social network, what they have experienced, what they recommend, that often shapes behavior in really important ways for understanding health equity concerns or bringing care to underserved communities, etc. We will talk about multi-level and multi-scale models and hybrid models in quite some detail within this class, and use that to look at really powerful ways agent-based modeling can be combined with several other types of dynamic modeling. As time allows, we will go into a little bit of discussion about how agent-based modeling is combined with deep learning in some recent combinations, which are intriguing, and which give food for thought. Right. I do want to note, though, that this course is not just about agent-based models, it's about agent-based modeling. And there's a very strong emphasis that I will be placing on discussing modeling, the modeling, the process of modeling. At the most basic level, the structure of that process, the key role of model scoping and conceptualization, which is considerably more texture to process for agent-based modeling. You have such an amazing wealth of flexibility that it's very easy to undercut your ability to pursue modeling because of over exuberance in putting components into a model. And I argue, and I will from this floor quite strongly, for parsimony and incremental model delivery in a form of modeling that I call agile modeling, agile agent-based modeling. And I would argue that for agent-based modeling, it is even more important to pursue than for pursue in an agile way than for aggregate modeling. And we'll be exploring some of those ideas. I also emphasize centrally in the modeling process the key role that model transparency plays. Agent-based models can all too easily be, and all historically all too often have been collections of code that are off-putting to stakeholders. Times have changed. There's less good modeling practices, appropriate supporting processes, and attention to declarative characterization can make your models vastly easier for stakeholders to understand and to critique. And that's not a point of vulnerability, it's a point of success, because modeling is learning. And it is through critique, it is through suggestions, it is through discussion of the model as a boundary object that multiple sides can understand that modeling the process is advanced. And agent-based modeling has special needs here. Special needs, particularly in terms of model transparency. We'll talk about participatory modeling in support of that process. This is an area in which our group has done a lot of work. And it's an area underserved in the agent-based modeling literature, but one which is getting more attention of late. And this really taps the ability often for models to serve as storytelling vehicles and to build up models with stakeholders, or at least to bring them into contact with the models very, very frequently for these exchanges, for these suggestions, etc. Okay, so those are some sort of broad themes here. I do want to note that this is a fairly demanding course. We'll be going through a lot of material. I'm hoping it will be interactive. And as I had mentioned in my opening comments prior to beginning the real lecture per se, I'm hoping to get a better AV setup here, audiovisual setup, so I can better watch the comments come in, the chat, so that we can have discussion there. And I'm hoping those in the room here can have some discussion as well. The course will be very much centered around projects, and I'm looking forward with those present to explore projects of greatest interest to your points of study and greatest concern. I need to learn more about those present, particularly those remote, to understand background, and I will be sending a survey to that end. I hope to adapt this course considerably to those backgrounds, including the example model shown, case studies presented, coverage and emphasis in lectures, and other topics. This course will quite liberally cross over disciplinary boundaries. So I will be mentioning concepts from biostatistics and in the statistical sciences, alongside those from dynamical systems, alongside some discussions that draw on ideas from computer programming and software engineering. That addresses the reality of contemporary agent-based modeling. And were I not to do that, I would be shortchanging students for preparing for the reality of delivering agent-based models. But it does require a certain tolerance, tolerance of learning about new areas, terminology, which I will try to communicate to those present. Right. It's possible we'll have one or two more people join locally. It's also quite possible, I know Shu Chen, who helped a lot getting this set up. He was really the instrumental person there at Fields. He reports that this course will be having people join, or the people will be able to join for this week. And so it's possible we'll get a few more. I know at least one more that has expressed interest in joining. So we'll have a diverse group, and hopefully that will be something that is valued by students. But just recall that it may mean sometimes being bored if I'm saying things that are evident to some. Sometimes it will mean stretching yourself. Okay, so one thing that's I've alluded to is this course is cross-listed. It's cross-listed, though, in three different ways. It's cross-listed between the Fields Institute as a Fields Academy course. We have people joining from the US as well as Canada here. But beyond that, it's cross-listed as an undergrad course, CMPT 498, and graduate course 898. This is in many ways a strength. It brings diversity to the table. And one of those insights you get from agent-based modeling is that far from being just a slogan, sometimes there can be real strengths that come from diversity. But there's no question there's going to be detailed complexity that comes from this. Hopefully not dynamic complexity, but detailed complexity. So I'm going to ask for people's patience because I'm sure I'll screw up here. Basically, I'm going to be working with two different learning management systems. Those registered in U of S side, 498, 898, are going to be using Canvas, and I'm going to be posting everything to there. And then those on the Field side are going to be using the Fields LMS, which is based on Moodle. And I'm going to be posting everything there. And I'm sure that I'll screw up somewhere. So just let me know if you don't see something. But when I post example models for use in class, to explore in class, I'm going to ask you to find them on your respective systems. If you go to submit things, you'll submit on your respective systems, and I'll just have to do the potato, tomato, going back and forth between them to find the appropriate submissions. Hopefully we can use these lectures and these slots, 4 of them a week, Monday, Wednesday, Friday, and then Thursday, for labs to sort of resync. Right. A word about office hours. I'm enthusiastic about interacting with students in office hours. And as many of you know, I like to generally hold office hours right after a class. And with this class, I would plan to do so for Wednesday and Friday sessions. I would like to do so for Monday, including today. The problem is that my department has 3:30s on Mondays slot reserved for departmental activities. And that means once a month, me having to go to a mandatory departmental meeting for faculty meeting. It also means on occasions like today, I have to help manage an internship program issue. So there will be many Mondays where I hope to hold office hours afterwards. It's just today, unfortunately, because of a long scheduled meeting, I'm not able to do it. But Wednesday, Friday, I'll hold office hours. Also, if you want to meet with me separately, reach out and we'll seek to do it. Just give me 10 minutes after class so I can relocate to my office because we may have another class in here. I think we do have another class in here, I think, after this one. Okay. We're going to be sharing a lot of models via the course learning management systems, Moodle for Fields LMS, and Canvas here at USask. And I'm going to be posting models here. There is a much larger library of models, and I give actually a dated link here. The truth is I want to update this. Models have been updated, extended, enriched. New models have been posted, but I gave this as an interim one. You can go find dozens and dozens of models here, which might be of interest. Okay. Time runs on, so I want to talk some about marking and expectations. What's expected? Well, the marking scheme is different for undergrads and grads, is commonly the case. For Fields Academy and CMPD 898, they share the same marking scheme. And basically, it's participation. You can see the breakdowns here, right? Take-home challenges, and that should really say take-home and in-class challenges. It's spelt out more detail on the syllabus, which is posted respectively to the sites. And then the project. I mean, really, for the graduate version, as is the case in many courses, the project occupies the plurality and sometimes the majority of the marks. So here it's a project based heavily with some take-home challenges and in-class challenges associated with it. There's no exam for the Fields Academy in 898, but I certainly welcome participants from that to the exam review sessions that I will hold. Right. For 498 for undergrads. Here we have pop quizzes. We have lab and in-class exercises. There's a lab component on Thursdays. Those from Fields Academy are welcome, and 898 are welcome to attend. I will be teaching it. I think it's in this in fact, room, and if not, it's in S311. And my plan is to teach that and to use the time for practical exploration of models and model building and really sort of hands-on components to complement the conceptual density of the lectures. But for undergrads, that's a component of the marking, the labs. Participation is again 5%. Project is 45%, and there's a mandatory final exam dictated by the rules of undergraduate courses. So the balance is a little bit different, but in both cases, projects are major. The really big ticket difference is undergrads have pop quizzes, grads don't, and there's a final exam for undergrads that graduate students do not, to which they are not, graduate students are not subject. Okay, What am I looking for projects? Well, projects can be individual, they can be group-based. I welcome either one. Um, Honestly, I'm very open to two ideas here. They can be building a model in an area of interest to you, what I call applications. They could be comparing different platforms for the sake of understanding their affordances. They can also provide a deeper look methodologically at agent-based model and or different frameworks for implementing it, etc. So methodologically, I would welcome contributions. Um, if some of these topics, interest you, multi-scale behavior, issues with low dimensionality, low dimensional manifolds coming from high dimensional systems, scaling behavior, aspects of characterizing agent dynamics with different formalisms, etc. Like you can pick particular things you're interested in methodologically, or you can just go deeply into a modeling challenge in an area of your interest and deliver on that. Any of them is good. All right, I welcome them, and I look forward to talking with you about them. I will ask, and this is one thing that the comparatively smaller size of this course allows, I would ask that we you're required to meet with me several times a semester. And so I ask for successive delivery in terms of problem statement for late January, model conceptualization and scoping, give suggestion as to frameworks, but basically you're conceptualizing the scope, what the model contains, and how it contains it. Many of those in this room will be familiar with the threefold division, which is of great value within an agent-based context, distinguishing things that are endogenous, that the model produces through its dynamics, exogenous, things that are represented in the model, but in a pre-specified way, sometimes invariant over time, sometimes changing over time, but in a pre-specified way. And then finally, things that are excluded from the model or ignored by the model, sometimes deliberately, sometimes just because you haven't thought to include them. So this second phase is really focused on conceiving, like, where's this model? What is this? What is included in this model initially, and where's it going? And that's due in mid-February. There's a break just after this, a semester break, a 1-week semester break. And this is due just at the cusp of that. In March, there's a further report which asks about analysis methodology, formulation, progress in the formulations, planning of scenarios and outcome measures, etc. There's a lot more in this in the respective syllabi. And then finally, on the final day of class, which is April 6th, there's a final report. Did you have a question, Nathaniel? Okay. Yeah, so I include in here some project ideas, but these are not at all privileged. They're just, seed some thinking. So this course is going to have many sessions of a very different character. But one thing that will be a recurrent component will be running models interactively within model sessions. We use this to illustrate properties of complex systems. We'll use it to compare and contrast aggregate models, agent-based models. We'll use it to learn about different ways of structuring models, different ways of specifying models, etc. And to do that, I plan to draw on several different frameworks and to be able to showcase models running in rather different agent-based modeling platforms. This would include the one in which many of our models will be encoded, which is AnyLogic, in which allows us to have hybrid model, but it would also include NetLogo, for example, and we'll show some likely in agents.jl, a Julia-based package. I may do some showing for an R-based package, the ABMs package from my colleague Junling Ma out in University of Victoria. And we'll also be showing some glimpses of this next generation project that I'm involved in, that some of you are aware of, with algebraic ABMs, which provides declarative way of characterizing model logic, and does so in a way that tries to keep the focus on what the model is doing and less on needing to reason about the details of how it captures that. But because we will be running AnyLogic quite a bit, including next session for this initial model I posted, I would like you to download the AnyLogic PLE. That's a personal learning edition. It is available for Mac, Windows, and Linux as well. And if you download that and install it, be sure to get the PLE. Don't get there's no need to get the professional or the researcher edition. It's the PLE that you. Okay. So please get that for now. In later sessions, we will I'll ask you to install things like NetLogo, possibly Repast, possibly Julia, etc. But for now, this is the one we're going to be using for the next few lectures. Okay, so those are my comments on course structure, expectation, etc. Now, I have a bunch of slides that are substantive, and I have some models to show, but given the limited time, I think what's more important is to use this time to answer questions, both from remote folks and from local folks here. So I am just going to, okay. So great. I see now that I'm looking at the chat, some questions. What would a final report be looking like? Well, I'll give you a sense of what the final report looks like. And I will seek to do so by, let's see, what's the best way to do this with workspace management? Probably the best thing to do is to just call up the syllabus for the fields version of this. And I am going to, it's a personal learning edition. Thank you for the question, Duncan. For that other question, but let me go and engage in screen sharing on the syllabus, and I will steer you towards the required section. Okay, here we go. Come on. Here we go. Okay. I should have noted, courtesy of Fields, these lectures are recorded. And I will be seeking to post them or have them available for people as soon as possible. What I want to highlight in here, though, first of all, is at a more high-level way, these dates, which I just rattled off from the slides, it spells out in somewhat more detail what is sought for each of these. However, what Duncan, I think, uh, more the topic of his inquiry was rather about the structure of the report. And what I suggested for application-oriented, this is important because this is not written in stone. This is not a fixed set of requirements. If you're pursuing a methodological study, the report can be structured rather differently, and you should discuss it with me and we can decide. But if it's an application-oriented project, generally I'd be looking for the following. Abstract background, and it spells out, what I'm expecting to see in background, what I'm expecting to see in a description of the model, at the level of scoping, architecture, formulation, etc. Any calibration, sensitivity analysis. This could additionally talk about more generally parameter estimation and calibrations, sensitivity analyses, scenarios, and importantly, critically, learning from the project. Models are learning tools. They help us debug our thinking. They help us think more deeply, more quickly, more thoroughly, more reliably through the implications of our assumptions. They allow us to capture those assumptions, that theory, in a form that's operational, in the sense we can ask, what's its behavior implied over time? And it follows that, a foremost deliverable from engaging with the model should be learning. Learning that could extend from learning about your domain interest, like if you're simulating something in a domain, learning about from the behavior of the model to help you think through issues in that domain. But it could also be comments on the craft of agent-based modeling and individual-based modeling. It could be frustrations that you ran into. It could be insights about things you were able to probe that you wouldn't have been able to with an aggregate model. It could be, comments on the challenges you ran into with specifying the model in a particular framework. All of these are really good topics. So learning, domain area, what you do differently, about the process side of modeling, etc. And then for future work. So I hope, Duncan, that gives you a more concrete.
Yep, that's very clear. Thanks.
Okay, great. And you'll find it in both syllabi, both the Fields one and the one for the USS students. Again, though, I do want to emphasize that outline was for more applications-oriented projects. If you are pursuing a methodological project, I welcome them just as enthusiastically. It's just what that will look like. The structure of it will be very, very different based on the topic you're examining. If it's combinations of agent-based modeling with deep learning, it will look very different from hybridizations of agent-based modeling with compartmental modeling or discrete event simulation. It would look quite a lot different from if you're doing something with categorical implementations of agent-based modeling. And trying that either alongside or as an alternative to more traditional approaches. So, as I say, for those others, I welcome those projects. It's just I can't provide a one-size-fits-all. We would have to discuss it. But for applications, which many students in my classes tend to enjoy doing, hopefully those will give you some ideas. Okay, any other questions I could answer right now? Nothing right now? Okay, well, uh, it is great to be with you to launch this class. I think we'll have a lot of fun over the course of the semester, and I will be working to further build up some of the materials I provided you, including, say, updated versions of those models. One thing is I'm just learning my way around the Fields LMS. The learning management system from Fields. I've actually done a fair bit with Moodle, but for some reason I'm having trouble with Fields LMS is a little bit different from the versions of Moodle that I've used. So I'm going to be structuring the learning management system contents and restructuring it to prettify it and more clearly break it out into systematic sections, etc. So I appreciate your patience as I likely, like you, get to know the Fields LMS. Okay. Oh, there's another question. Great. As for some of the modeling project to be studied in this course, is there any basic knowledge required from us? Um, uh, no. It's not like I'm going to be expecting an understanding of the basic reproductive number or, that you have backgrounds in ODEs, ordinary differential equations, for this course. So it's not that I'm going to be expecting knowledge of networks and network science or graph theory or anything. So nothing like that. I will say that this course is geared heavily towards speaking to students who have some past glimpses, at least, of dynamic modeling. Um, and, I could add a module of one or two lectures. It would not be hard. I mean, like, it's like something I can almost do in my sleep. On motivations for dynamic modeling and that sort of highlight commonalities among all dynamic modeling traditions and how they serve to in the scientific process and potentially how they relate to other tools within the toolbox of people seeking to understand systems in the world or make decisions. Like, I could do that. Just because there's an opportunity cost imposed by doing that, I won't be doing something else. I'd want to make sure that it would be viewed as valuable by some people. So I think what I'll do is I think I'll send out a survey to students where they can say something about their background with respect to that. And that could allow me to better target my comments, particularly with respect to these foundational ideas of like the dynamics of complex systems and why we model and something about the common themes of dynamic modeling and common terminology, things like talking about state space or the state of a system and its evolution over time. Um, uh, Use of a term like emergence. I don't want to just assume that everyone has seen it if only half have. So let me see if I can do that. So in return, what I'm going to ask is, especially those who are remote here, especially those joining us through Fields, I'd ask you to fill out that survey by Wednesday so that I can, on Wednesday's class, I can comment on my plans and potentially launch into some of this background material if it's needed. Okay? If it's only like one person who feels they benefit by it, I'd rather do it in a special session, like a special office hour session, which could be scheduled and I give a briefing on it, and others could attend but don't have to, rather than using one of the lecture slots. That's my idea. Okay. Okay. It's awesome to be with you folks. Thank you, everyone. And we may have some others joining before next time, but I look forward to exploring this semester with you. Thanks, and you'll see me busy on the sites. Take care of that.